everyone, this is Shreya and today we are going to solve a problem on the topic of circular motion. This is a very important topic and the problems on this topic come very often on the competitive exams like JEE Main, JEE Advanced and NEET. Now, quickly look into the problem statement. So, here we are given that this mass M is attached to a string, okay? And the length of the string is given R. Now we are asked if at this angle 30 degree, if the tension at this point is 0, then what is the velocity at this point A? What are we given? We are given the tension at point P is 0 and we are asked about the velocity at this point A. How can we find this out? We can find this out by balancing the forces. If tension at this point is 0, now think about what force will be providing the centripetal force required. That will be the gravitational force. So the component of gravitational force which will be acting towards the center, that component will provide us the required centripetal force. So from this point, the mg will act in the downward direction, right? Look at this angle. This angle is 30 degree. This is 90 degree. So this angle will be 60 degree. The component of gravitational force in this direction will be mg cos 60 degree, right? This component will be providing us the required centripetal force at the point P. So we'll just write down this equation. This is the formula for the centripetal force, which is mv square by r. That is equal to this component of the gravitational force, which is mg cos 60 degree. What is the value of cos 60 degree? That is 1 by 2. So this comes out to be mg 1 by 2. Now simply cancel out this m on both sides. What will you get? You will get that vp square is equal to, I will go in this direction, rg divided by 2. Okay. Now, we have got what will be the value of velocity at this point. But we are asked what is the velocity at point A, not at point B. How can we find out this? Just think about it. Like, can we use the conservation of mechanical energy here? Yes, definitely we can. Because here the force is acting is gravitational force and the gravitational force is conservative force. So, we will use the principle of conservation of mechanical energy. And the principle of conservation of mechanical energy says that initial kinetic energy plus potential energy, the sum of these two will be equal to the kinetic energy plus potential energy sum at the final point. At all the stages basically, at all the points kinetic energy and potential energy will be constant. Their sum will be constant. So let's put the value of the kinetic energy. Kinetic energy at point A. This will be half mva square. At this point, height, let's say we consider this is at this level, the potential energy is 0. Okay, so we write potential energy as 0. Then we have to, what will be the kinetic energy at this point P? That will be equal to half mvp square. What is Vp square? We already calculated that as Rg by 2. So this will be half m Rg by 2 plus potential energy at this point. Let's say this total height. Let's consider this total height is h. So potential energy will be mgh. Here half mv square as it is. Now how much this will be? mRg by 4. Now we need to find out how much is this h. This h will be this length, which is definitely r, and we need to find out how much this will be. This is r and this will be how much? This will be r by 2 because this r, this component will be r cos 30 degree and this component will be like basically this length. This length will be how much? This will be r sine 30 degree. And how much is sine 30 degree? 1 by 2. So this length is r by 2, this length is r. So height will be r plus r by 2, which is equal to 3r by 2. So let's substitute this value of height here. Now we will get mg 3r by 2. Now what we have to simply do is we will simply cancel out the common values. M cancel out. This 2 and this will cancel out. Here we will be left with 2 and this will cancel out. Here on the left hand side we are just left with VA square. Here RG by 2 and here 3RG. If we will sum these two terms, we will get 7RG by 2. But this is equal to VA square. VA will be how much? This is equal to under root of 7RG by 2. Look, this problem was very simple. We just needed to apply the conservation of mechanical energy and we just needed to balance the forces. And we simply need to know if tension is 0, then all the centripetal force will be provided by the component of gravitational force acting towards the center. That's all. Thank you.